Right, we're going to go a little bit longer because of the delay. I hope that's okay. Because normally I finish at about 50 minutes. We're going to do one more video, how to determine the limiting reactant. This could be a 2 or 3 mark exam question. I can see there are still 23 of you. You've stayed along the whole way. Really, really well done. We're going to do how to determine the limiting reactant. This question comes up and it's a classic question. Oh, this video, let me just classic question. In any chemical reaction, by the way, you've always got, generally speaking, you're going to have a limiting reactant and then a reactant that is in excess. Generally speaking, there are going to be some chemists who might watch this and be like, "What is he on about?" But listen, generally speaking, that's what you come across. Now, in a reaction, a limiting reactant is the reactant that gets used up first in a chemical reaction. Okay, this can also be known as the limiting reagent. So let's say we've got sulfuric acid reacting with the base copper oxide, the salt, copper sulfate, and then water forms. Now, if we want to obtain copper sulfate crystals, we are going to need to add copper oxide in excess. This is now acids and this is making soluble salts recap. So look, here we have sulfuric acid and we add copper oxide in excess. This is to ensure all of the sulfuric acid has reacted. We then get copper sulfate, and at the bottom of the beaker is the excess copper sulfate. We know that the reaction has stopped when there is no more fizzing at all, and the copper oxide stops reacting and then remains at the bottom. Those are observations of what you can see to know the reaction has finished. Now I'm going to explain what does it mean when we say that copper oxide is added in excess. Let's say this orangey red circle represents one molecule of sulfuric acid. This one blue circle represents one compound of copper oxide, CuO. For every, now this is really simplified, the ratio of moles isn't necessarily correct based on what happens in the reaction. But for every, in this case, every time a sulfuric acid molecule reacts, a copper oxide molecule reacts. And we can show this because then the copper sulfate forms over here. Now look, what may happen is, let's say once all the sulfuric acid has reacted, 1, 2, 3, 4, 5, 6 of the copper oxides have also reacted. So look, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So all of the sulfuric acid is now gone. It's no longer in existence because copper sulfate and water has formed. And because sulfuric acid has run out first, and we have copper oxide left over in excess, automatically the sulfuric acid is in excess. Sorry, the sulfuric acid is the limiting reactant and the copper oxide is in excess. So because the sulfuric acid is used first in the reaction, it is the limiting reactant. It is just the reactant that gets used up first. And then copper oxide is added in excess, okay, remains at the bottom. And this is the reactant which remains when all the other reactants have been used up. This is quite a simple concept to understand. But how do we then do this in a calculation? How do we then do this in a calculation? Firstly, let's quickly just do question time, just so I know you're following. The reactant that gets used up first is known as the what? 1, 2, or 3. 3, 2, 1, and go. Oh, I see lots of ones. Is there a smarty pants amongst us? Number 3 is both of them. It's known as the limiting reactant or the limiting reagent, remember. You'll see it in different textbooks. Limiting reactant, limiting reagent. Reactant and reagent are synonyms of each other. They have the same, essentially the same meaning. Next one. This one's not easy. The reactant which remains when the reaction is over is the 1, 2, or 3. 3 to 1 and go. Easy, of course, number 3. Let's just move on. Everybody gets that. All right. Here's a real exam question. 20 grams of calcium reacts with 18.25 grams of dilute hydrochloric acid, which is the limiting reactant. You can get this as a 2 or 3 mark exam question. where you can't just guess. You have to show you're working out in order to guess, in order to say your answer. Now, I'll go over the question there. We then use this formula triangle. Mr. Mole is squashed by the mass, and we can see there is 1 mole of calcium reacting with 2 moles of hydrochloric acid, which is the limiting reactant. And we've been told there are 20 grams of calcium and there are 18.25 grams of dilute hydrochloric acid. So look, in the space that we have to work out, we write Ca and then HCl, okay? And like I said, we do this technique, mass AR mole because it's a metal, mass MR mole because we have a molecule here. And then look, we write in the information, there's 20 grams of calcium, and 18.25 grams of hydrochloric acid. So we write in this information, 20 grams of calcium, 18.25 grams of dilute hydrochloric acid. Notice at this point, you haven't got any marks, but it's going to help you get the marks. So now look, the AR of calcium is 40, and the MR of hydrochloric acid is 36.5. Notice I'm not multiplying the 2 to make that 73. Now, at this point here, we then use the equations to calculate moles. Mass over AR or MR, so we calculate the moles. We know that from a previous video how to do that. So we calculate the moles. Now we can see that based on these masses, there are 0.5 moles of calcium and then 0.5 moles of HCl. So you're probably thinking, what do we do with this next? Based on this, we can see that the ratio is 1 to 2. So because of that, if the ratio is 1 to 2, we should have, if there's 0.5 moles of calcium, there should be 1 mole of hydrochloric acid. Or if there's 0.5 moles of hydrochloric acid, there should be 0.25 moles of calcium. This is how you figure it out. So therefore, because there is more calcium than there should be 0.25 moles of calcium. This means the calcium is actually in excess. Okay, there should be 1 mole of HCl. So HCl is the limiting reactant, whereas calcium is then the excess reactant because there should be 0.25 moles. And that's literally how you do it. So you just calculate the moles, and then you look at the ratio and you see which one should there be more of, which one should there be less of. Done. That is it. Why is it AR for, it doesn't matter if I'm honest as a pure chemist. AR is for individual, is for one atom, MR is for a molecule, and calcium is we're talking about one atom here, and HCl is a molecule, okay? We got 36.5 because of the MR of HCl. One hydrogen atom has a mass of 1, and then one chlorine atom in HCl has a mass of 35.5. 1 plus 35.5 equals 36.5. That's how you get the MR of HCl. Yes, calcium. No, HCl is a limiting reactant because when now we've calculated the moles, there is 0.5 moles of calcium and 0.5 moles of HCl. If we use the ratio, this is saying for every atom of calcium, 2 molecules of hydrogen chloride are produced. The ratio is 1 to 2. So therefore, for every 0.5 moles of calcium, there should be 1 mole of HCl. So hydrogen chloride is a limiting reactant. So the one that doesn't equal the ratio. Yes, Kelsey. Yes. Okay, yes, definitely. Let's do another one. This one is, okay. I would like you to try and figure this one out by yourselves. So look, you need to do 1.75 grams of lithium reactant 8.0 or 8 grams of oxygen. You've been given the relative atomic masses. Just focus on lithium and oxygen. Do AR of lithium, because it's just one atom. So AR, no, mass AR mole. And then O2 mass MR mole. Calculate the moles. Okay, and the ratio is then 4:1. So then use that ratio to help you. Do you know what? I know people are going to be struggling with this. I'm just going to go through it. Here is do you know what? No, I'm going to give you a little moment to figure out. I'm actually going to give you a moment to figure it out. Off you go, please. Try and think for yourselves. Questions? Any questions? Oh, let's see if you're right. Okay, 30 more seconds. 30 more seconds. Any questions there? No questions. Okay, no questions. Okay, let's go through this. We've been told lithium is a limiting reactant. How do we get there? Look, mass AR mole, mass MR mole, 1.75 grams of lithium, and the AR is 7. When we calculate the moles, 0.25 moles. 0.25 moles of oxygen there is also 0.25 moles of oxygen based on 8 grams divided by 32. Now the ratio is 4 atoms of lithium for every 1 molecule of oxygen. Therefore, if there are 0.25 moles of oxygen, there should be 4 times more than that. There should be 1 mole of lithium. Okay, because the ratio is 4:1. And because of that, lithium is the limiting reactant. Sadia, what was your question? Tell me now, ask me now, please. So look, what you can do, you've got these gap fills here, and you have these exam questions, which are real exam questions. Okay, that is literally a 1-mark exam question. What does it mean if a reactant is in excess? Now, please, I hope you enjoyed this. I pray that you got something out of this.